We will now proceed with the last section of today's topic. We will now talk about abstract data types. An abstract data type is a data type which consists of a collection of values together with a set of basic operations defined on the values. A data type is an abstract data type if programmers using the type do not have access to the details of how the values and operations are implemented. Which means programmers can simply use those kind of data type without having to worry how things are implemented inside those ADTs. There are classes to produce ADTs. To define a class so it is considered as an ADT, we can separate the specification of how the type is used by a programmer from the details of how the type is implemented. After all, what matters the most is that programmers will know how to use a given ADT without having to worry how things are done or implemented inside of it. To do this, we make all member variables private members. Basic operations a programmer needs should be declared as public member functions. We also need to fully specify how to use each public function. That is where sensible comments will come into play and show us how important they are. Also, helper functions should be private members. Now let's talk about an ADT interface. The ADT interface tells us how to use the ADT in a program. It consists of the public member functions, the comments that explain how to use the functions. In these comments, we will usually see preconditions or the conditions that needs to be satisfied when using such member function. And we also have the post condition or the resulting condition right after the function was executed, given that it was provided with the right parameters. The interface should be all that is needed to know how to use the ADT in a program. So how do we do the ADT implementation? The ADT implementation should tell us how the interface is realized in C++. This consists of the private members of the class, the definitions of public and private member functions, and the implementation is needed to run the program. The implementation is not needed to write the main part of a program or any non-member function. As we have already mentioned, all that a programmer needs to see is how to use the ADT and what the required input should be and what the output should be right after the ADT was utilized. In this case, it could be in the form of member functions. What are the benefits of using ADTs? First, changing an ADT implementation doesn't require changing a program that uses the ADT. Next, ADTs makes it easier to divide work among different programmers. As a result, one or more programmer can write the ADT while the others can simply utilize it. Also, one or more can write code that uses the ADT. Writing and using ADTs breaks the larger programming task into smaller tasks, therefore making the programming project more manageable. Here's another example which shows an ADT. Basically, this is still the same program, only that a few portions of it were changed. Therefore, in this version, data is stored as three member variables. As you can see in this example, previously, the member variables were only the amount, which would represent the balance, and the interest rate. In the new version, we have the following member variables. In this case, the dollars part and the cents part were separated. Also, in this version, it stores the interest rate as a fraction. As we can see here. By doing so, where we keep the public portion of the class definition unchanged, we have the concepts such as interface preservation. But what is interface preservation? In this concept, we would like to preserve the interface of an ADT so that programs using it do not need to be changed. In this case, public member functions or declarations cannot be changed. Also, public member definitions can be changed. On the other hand, private member functions can be added, deleted, or they can even be changed. This gives way to the concept of information hiding. Information hiding is actually a very popular concept in object-oriented programming. Information hiding was referred to earlier as writing functions so they can be used like black boxes. In this case, ADTs implement information hiding for the reason that first, the interface is all that is needed to use the ADT. As we have mentioned earlier, what matters the most is that the programmers will know how to use the ADT. That is, what input is required as well as the output, which will be a result of the execution of such ADT. Thus, the precondition and the postcondition. It is also for the purpose that implementation details of the ADT are not needed to know how to use the ADT. That is, we don't have to worry about how the actual ADT was implemented as long as we know how to use it by providing it with the right input. Also, implementation details of the ADT and the data values are not needed to know how to use them. And that ends the section about ADTs. We now know what an ADT is. We can now describe how to implement an ADT in C++. We can now define the interface of an ADT. And we can also define the implementation of an ADT. And that ends our chapter for classes. Thank you.